Today we'll continue our discussions on linear algebra, and we have another two problems here. The first one with two variables or two unknowns, and the second one we have four, no? Three variables, no? Or three unknowns. So to start with, we have these two equations here. 3/4 x minus 3/5 y is equal to 4. And the other one is 1/4 x plus 2/3 y is equal to 1. We are asked to solve this and find a unique solution for the system of equation here. Now first, you're going to write the coefficients of the variables into a matrix form. So just copy the numerical coefficients. We have here 3/4 minus 3/5 is equal to 4, which is 4 here, and 1/4 and 2/3 and 1, no? So as you can see, we have fractional exponents here. So to make things easier to compute, we just convert these fractional exponents into whole numbers. So we multiply the first one by the LCD and also the second one, no? The LCD for the first equation is 20. The LCD one for the second equation, or for row 2, is 12. So if we multiply 20 times 3/4, we're going to get for our solution 15 minus 12. 3/5 times 20, no, is negative 12. No, and 4 times 20 is 80. And the second one, 1/4 times 12 is 3, and 2/3 times 12 is 8, and 12 times 1 is equal to 12. So you have this matrix form, no, 15 minus 12 and 80, and 3, 8, and 12. So you will notice, no, if we multiply R2 by 15, no, the row 2 by 15, and subtract our answer, our product, to the row 1, we're going to get 3 times 5 is 15, minus 15 is equal to 0, 8 times 5 is 40, minus 12 is equal to positive 52, and 12 times 5 is 60, minus 80 is negative 20, no? So as you can see again, no, you study this carefully. We have for our row 2, we have using box substitution, we are only left with one unknown. So 52y is equal to negative 20, and solving for y, we have here negative 20 over 52, and change this lowest term, we have negative 5 over 13. And to continue our box substitution, from row 1, we're going to use this one. 15x minus 12 times y is equal to 80. We just substitute the value of y, which is negative 5 over 13 is equal to 80. And then 15x, negative is positive, so 12 times 5 is 60 over 13 is equal to 80. And then we transpose this 60 over 13 to the right side of the equation. So we're going to get 15 over x is equal to 80 minus 60 over 13, and we get 1080, no? 1040 minus 60, and we have the LCD to be 13. No? So 1040 minus 60 is equal to 980 over 13. So we have here, to get the value of x, we divide both sides of the equation by 15. So 980 over 13 minus, times the quantity 15. So 980, no, divided by 5 is 196. And then the 15 divided by 5 is 3 times 13 is 39. So our solution for this two given equation here is for the value of x is equal to 196 over 39, and for the value of y is equal to negative 5 over 13. So we have this solution here for our first problem. We're going out to the second problem. Again, we're going to use Gaussian elimination to solve the system. And we're given the system here, 3x plus y plus 3z is equal to 9. And 4x plus y plus 2z is equal to 13. 7x plus 2y minus 1 is equal to 24. So again, we're going to use only for the mixed forms the coefficients of each variable. Just copy all the coefficients here. 3, 1, 3, and 9. 3, 1, 3, and 9. And 4, 1, 2, and 13. 7, 2, negative 1, and 24. So after studying this carefully, we want to transform this into the row echelon form. To do that, we get to have a positive 1 to our first row here. So we just interchange row 1 and row 2 and get this value here for 1, 2, and 13. You just copy, 3, 1, 3, and 9, 7, 2, negative 1, and 24. So we now have a larger row 1 here. So 4 minus 3 is 1. 1 minus 1 is 0. So the difference will be, we will write the difference in the row 1. So 3 minus 1 is equal to 3 minus 2 is negative 1. And 2 minus 3 is negative 1. 13 minus 9 is equal to 4. So we just copy again all the other coefficients, 3, 1, 3, and 9, 7, 2, negative 1, 24. So having this equation here, as you can see, we have 2 1s here. So you want to make this as much as possible to be 1. So, or 0 here, So to do that, we're going to subtract row 3 from row 1, So this one is row 3, row 3 minus 2r2, 2 times row 2, So we have here row 3, 7, 2, negative 1, and 24, minus 2r2, So we have here 2 times 3, is 6, 7 minus 6 is equal to 1. 2 minus 1 times 2 is equal to 2, so we get here 0. And this one here is negative 1 times minus, 2 times 3 is equal to negative 6 plus negative 1, so we have here negative 7. And then the row 3 is 24 minus 9 times 3 is 18, and we get here 24 minus 18 is equal to 6. Having this solved here, so as you can see here, we can still make this one simpler, Make this one simple, the third row here. We can do that by making the other one here, a 0, So row 3 minus row 1, as you can see, is we will subtract row 3 minus row 1. Row 3, 1 minus 1 is equal to 0. 0 minus 0 is equal to 0. Negative 6 minus 1, which is positive 1. Negative 7 minus 1 minus 1 is negative 6. And 6 minus 4 is equal to 2. So if we'll examine this carefully, we can now use our back substitution from row 2, or row 3, So we have here only one variable here, negative 6y, x, y, z. The negative 6z is equal to 2. So negative 6z is equal to 2. So we divide both sides of the equation by negative 6. We have here z is equal to negative 2 over 6 or negative 1/3. From row 1 here, since we have the value for z here, to be negative 1/3 from row 1, x plus 0 minus z is equal to 4. The value of z is equal to negative 1/3. So we have for the value of x is equal to x minus x plus z. We change the sign here. 4 plus z is equal to 4 minus 1/3. So this one is 12 over 3 minus 1 over 3 is equal to 11 over 3. So the value for our x is 11 over 3. So from row 2 here, since you have used the two equations here, you just substitute the two variables in row 2. So 3x plus y plus 3z is equal to 9. 3. The value of x is 11 over 3 plus y plus 3, and the value of z is equal to negative 1/3. That is equal to 9. So solving for the value of y here, simplifying the equations here, we're going to get y is equal to negative 1. So the value for x, y, z, for x is 11 over 11 over 3, y is equal to negative 1, and z is equal to negative 1/3. So that's how we're going to apply the Gaussian elimination method. And thank you again for watching our video. And please don't forget to subscribe. And if you have any suggestions, please send it to us in Tagalog or English so that we can improve our way presentation. So thank you again and see you again later.